In this video, I'm going to show you how to simulate mortality rates data in Python. So by the end of this video, you should be able to simulate a mortality rate data to look like this. Where you see a very nice mortality table like this. So you see the different years and then their respective mortality rate based on the ages here. Okay. Alright, so to begin with, we need to import our necessary libraries. So in this simulation, we are going to import numpy as np and then pandas as pd. Okay, numpy will be used for handling the arrays, and then the pandas will be used for our data manipulation and then analysis. Okay, so let's go on and then uncomment this and then run this particular code. Okay, so after we are done importing our libraries, we need to set a random seed. Okay, so let's set the random seed to 42 using the numpy.random.seed. Okay, this particular code ensures that when you run the code over and over again, the same random numbers will be generated. Okay, so let's go ahead and then uncomment this and then run it. Okay, so after we are done setting our random seed, we need to define our range. Okay, so what we need to do is to create an array of years and then ages using the numpy.arrange code. Okay, so here we are saying that we need the mortality data from 1980 to 2020. Okay, it will be backdated 1 year. That's why we did it 2021. Okay, same for the ages too. Okay, so from age 0 to age 100, you get it. So let's go ahead and then uncomment this and then run this code. So after we are done defining our range, we need to generate a grade. Okay, we need to generate a grade of all the combination of the years and then the ages. And then to do that, we need something we call a library from numpy called merge grade. Okay, this will create a two-dimensional array, that is the years and then the age. Okay, that will represent all possible combination of the years and then the ages. Okay, so let's go ahead and uncomment this and then run it. All right, so after we are done finding the combination of the years and then the ages, okay, we need to flatten the ages, that is set them into one column. Okay, so that we have maybe 1980 to 2020, the mortality rate for age 0, and then same for the rest of the ages. Okay, so let's uncomment this and then run it. So after we are done setting the arrays for the years and then the ages, the next thing to do is to specify the mortality rate equation. Okay, so in this one we are going to use a log linear mortality equation. Okay, so here the coefficient of age, okay, which is negative 0.02 for the age flat, it represents the general trend that mortality rate increases with age. Okay, in actual sense it is true, right? So as age increases, the mortality rate will increase. Okay, because older people tend to have a higher mortality rate than younger people. Okay, so that is the coefficient here. And then for the year here, the coefficient of the year here, that one too also represents the trend that mortality rate may decrease slightly over time due to maybe improvement in healthcare. And in actual sense, it is true, right? So as the years are progressing, there are so many medical breakthroughs that has had an impact in mortality rate. Okay, that is why that is positive here. So in order to get a realistic data, or maybe our data to look realistic, we need to add some noise to it. And then we are going to take that noise from the normal distribution, okay, with a mean 0 and then standard deviation 0.1. Okay, so we are saying that the size is the number of years that we have here. Okay, all right, so let's go ahead and then run this code. Okay, so remember we are using the log linear mortality rate here. So after we are done generating that data, we need to convert it to 8 general mortality rates form. Okay, so to do that, you just have to find the antilog of it. Okay, so let's go ahead and then uncomment this and run it. Okay, so we are done generating our data, but then we need to store it in a data frame format. Okay, so let's create a data frame that has 3 columns. That is year, age, and then mortality rate. Okay, which is populated with the values from the year flat. From the year flat, that's the number of years that we have. All right. Okay, so to do that, we are going to say that. Let me uncomment this first. So to do that, you are going to say that the first column, that is the year, should be the year flat as we have here. Okay, the number of years that we have, which is like 41 years. Okay, then the age, the age should be the age flat that we had. When you generate the data, you see how it looks like. And then the mortality rate is going to be our mortality rate here. Okay, so let's go ahead and then run this. Okay, so let's check some portion of the data to see if our data has been generated indeed. So let's use data.head to view the first 5 rows of the data. Okay, so let's run this. And now you have your mortality data. Okay, so as you can see, year, age, and the mortality rate. So this is for age 0. Okay, to see that indeed all the ages has been generated, you can view the tail of the data. Okay, data.tail to give us the last 5 rows of the data, and you are going to see that the ages are going to be age 100. So you have from 1980 to 2020 for age 0, 1980 to 2022 for age 1, and the same. Okay, so let's run this, and you are going to see that this one is age 100. Okay, and their data ends in 2020, right? Great. So after we are done generating our data and we view the portion of the data, let's store it as a CSV file so that you'll be able to download it for maybe other analysis also. Okay. So to do that, remember you have to use the data.csv. Okay. Maybe this year the name data here is because we named our data as a data. Okay. Data.tail. Remember here. Okay, so the name that you are going to use here should be the name here. Okay, so maybe you use mortality rate here. Then it means here too you are going to use mortality rate dot to CSV, and then you name it with the name you want to give to the data. Okay, so let me uncomment this and then explain it. So here we are going to say that the name of the CSV file should be simulated mortality rate.csv. All right, so we are setting the index to be false so that it wouldn't be included in our data. Okay, else the index will be included in the columns. If you want to understand it more, you can watch the previous video, which I will be providing it in the description below, and then you will be able to understand why we are setting the index to be false. Okay, all right, so after we've done, let's run this. Okay, so after we are done saving our data to a CSV file. Okay, when you want to access the data, you can come to your home here, and when you scroll down, you are going to see your data here. Okay, simulated mortality rate.csv. You will see your data here, and you'll be able to download it. Okay, if you want to download it, you can just select it and then download it here. All right. Okay, so maybe you want to do your analysis in Python. You want to go ahead and do your analysis in Python. So what you have to do is maybe to read your data, okay, using pandas. So maybe pd.read csv and then the name of your data, and you can view a portion of your data to see that indeed it is your data. Okay, all right, so it looks like this data isn't that nice enough. Okay, so we can actually change it to a pivot. We can transform the data frame to a pivot table with years as columns and then maybe the ages as rows. Okay, so to do that, we are going to use pivot. Okay, particular library called the pivot. So the name of the data dot pivot. Okay. So let's uncomment this. And we are going to say that the index should be the ages. Okay, so maybe the age should be the index, and then the column should be the years. So maybe you have this is 0, the its mortality rate for 1990, and then the rest, and the value should be the mortality rate. So let's go ahead and then run it, and we are going to see a very nice mortality rate data here. So you have 1980, age 0, their mortality rate; age 1, their mortality rate; age 2, their mortality rate; age 3, and same for all. Okay, then you have for all the years from 1980 to 2020, so you can check it here from 1980 to 2020. All right. Okay, so maybe if you want to save this particular data to as a CSV file, then you can use the same .csv to store your data. So here we are going to say that the name of the data should be pivot simulated data.csv. So when you go ahead and then run this one, we are going to see our data here, pivot simulated data here. You can choose to download it. Okay, I'm going to provide the code in the description below, and then since you've gone through this code together, I'm going to provide the link to the code for you to go through yourself. Okay, all right, so don't forget to subscribe to get more content like this. All right.